wabarakatuh. Today we are going to present chapter 4 about boiler operation and maintenance. Okay, firstly, before that, boiler prime mover is water. Therefore, it must be treated first. Okay, why it must be treated? To remove suspended and dissolved solid. It's classified into two, external and internal. Okay, what is impurities? Impurities cause excessive corrosion and harmful scale formation, and also forming in boiler, resulting in deposit at turbine wheels. Okay, for treatment, we can maintain the pH, chemical treatment, and blow down. Okay, what is blow down? Blow down is a portion of water removed from boiler. This is done because chemical treatment is ineffective. About 5 to 10% of water is removed. Okay, next I will pass to Ifan.
Okay, I will present about the boiler application and operation. First, this boiler use water. The water used to produce the steam, and then the steam is used to operate turbine, distillation system, and reaction system. The simple boiler consists of water drum, heat source, water inlet, and steam outlet. Drum is heated, then the water boils. After that, the steam generates, and finally steam goes to the next process. Okay, for the fire tube boiler, it is modified shell and tube heat exchanger. Hot gases from fire pass through the tube, running through sealed container of water. Heat is transferred to the container wall by thermal conduction to heat up the water to steam. Okay, next, I proceed with Amy.
Okay, next is water tube boiler. Water tube boiler ni dia ada fuel burn inside the furnace. Water feed water dia ada terbagi pada upper drum dengan lower drum. Mana water enter feed water drum and goes upward to steam drum. Water is heated during the journey. The saturated steam is drawn off at top of drum to the superheater, and saturated steam change into superheated steam. Cool water from steam drum returns to feed via downcomer tube to be reheated again.
Okay, steam system. Steam flow from boiler to the plant. It begins to cool. As it cools, condensate is formed. Condensate cause many serious problems. Slush of water can damage equipment and lead to water hammer. Water hammer is a pressure surge or wave caused when fluid in motion is forced to stop or change direction suddenly. Steam traps are used to remove condensate. Steam trap is a device used to discharge condensate. Steam trap divided into two categories, mechanical and thermostatic. Mechanical include inverted buckets and floats, while thermostatic include bellows type traps.
Steam traps can be divided by two, namely which is mechanical steam trap, temperature steam trap. Mechanical steam traps is they have a bucket or float that rises and falls in relation to condensate levels. Also, a mechanical linkage is attached to open and close valves. Example: inverted bucket float traps. Next is temperature steam traps. They have valve that is driven on or off by either expansion, contraction caused by temperature. For example, thermostatic traps. The difference is differ from mechanical traps in that they are designed to hold back some condensate, waiting to cool sufficiently to allow valves to open.
Hi everyone, I'm Ted Heiderscheid. I'm here today with this 3-pass fire tube Scotch Marine boiler. I'm here to talk to you a little bit about maintenance and operation of this boiler that will help you maintain it in a high state of reliability, help you increase the useful life of the boiler, and hopefully help with energy efficiency, which will help keep a few dollars in your pocket. few things I'd like to talk about are, one of the things is our leading cause of loss is localized overheating in these type of boilers. This can be due to a couple of key factors: low water conditions in the boiler, scale, corrosion. These are some of our leading causes of loss with steam boilers. Let's talk about a few ways to prevent those in order. We talk about low water conditions. Those are one of the leading causes of accidents. This boiler has 2 low water fuel cutouts on it. So anytime to have a low water accident, you have to have several things happen. First of all, you have to have a problem with your feed water. This could be due to the feed pumps, the feed controllers. So that's going to be the original source of the problem. But we've got safeties on the boiler. The low water fuel cutouts are designed to shut down the burner of the boiler before the water level gets to a specified area. The key is if the water level drops below, for example in here it drops below the tube surfaces, now we've got flame going through the tubes, it can overheat the metal of the tubes, and we get things like melting of the tubes, and just bad things happen with the boiler when we get low water. Let's talk about scale a little bit. Scale happens because of impurities that are carried in the feed water. As a steam plant operates, there's going to be steam losses in the system. To make up for those steam losses, there's going to be makeup water that's brought into the steam system. That makeup water carries impurities with it. There's a tendency, if the water chemistry is not kept right in the boiler, for those impurities to plate out on the internal surfaces of the boiler in the form of scale. That impedes the heat transfer from the fireside surfaces of the boiler to the waterside surfaces of the boiler. This impacts reliability of the boiler, the life expectancy of the boiler, and energy efficiency. So, if we can correct the water chemistry in the boiler, then we're going to make a big improvement to those things. You should always work with your water chemistry representative to maintain that program. Balancing things like blowdown of the boiler, the amount of chemicals and the type of chemicals in the boiler will go a long way. Another key factor in maintaining the water chemistry of your boiler is treating the incoming feed water. In many places, the incoming feed water has a lot of impurities in it. A way you can address that is by installing a water softener. That's something you can talk with your local water chemistry representative about. The water softener has to be regenerated from time to time. You have to add salt to make sure the water softener is working properly. But the key is you're going to get good, clean water into the boiler. That's a great foundation for the water chemistry program, and it's going to help you prevent scale buildup in the boiler. General corrosion is another thing that can lead to boiler loss. One type of corrosion in the boiler is oxygen pitting. In the boiler, you'll see orange bubbled up marks on the tubes. As you move those bubbles away, what you'll see is it's drilling down into the tubes. You'll see craters in the tubes. As those drill down into the tubes, if they get bad enough, they're going to leak. They're going to cause a leak from the water side surfaces of the boiler to the fireside surfaces of the boiler. We'll see corrosion coming out of the tubes if it gets bad enough. The only way to correct that, once it gets bad enough, because they'll be on all the tubes. So when one leaks and you fix it, next thing you know, there's another tube leaking. So at some point, the only way to really get rid of the problem is A, get rid of the oxygen in your boiler, but B, you're going to have to retube the boiler eventually. At least that point, you can kind of start over. If you get your water chemistry program straight, it's like you have a new boiler again. Your boiler can be more efficient, more reliable.
Okay, that's all from us. Thank you.